So the first thing whenever we're given a set of or a vector space, we need to know what the vectors are and what the operations are. Well, the vectors are linear transformations. So the vectors are T in the set L, V, W is a linear transformation from V to W. And now we need to know what addition and scalar multiplication is. So T, our addition operator, S, this here is defined as T plus S, and I'm just going to be doing regular addition instead of uh, uh, box addition of V equals T of V plus S of V for all V in V, where T of S plus T, or T of V plus S of V uses the addition in W. So it uses the addition in W to define the addition of linear transformation. And C times T is defined as CT of V equals C times T of V, all V in my vector space V, where C times T of V uses the scalar multiplication in W. So in both cases, I'm using the addition operator in W and the scalar multiplication operator in W. And it's true for all V in V. And this is how I define my addition, and this is how I find my scalar multiplication. So the two properties that we first need to show is that the addition operator maps two linear transformations to a linear transformation. Because remember, our V here is the set of linear transformations. So let T and S be in the set of linear transformations mapping V to W. Consider T plus S. What we want to show is we want to show that T plus S is a linear transformation. Well, to show this, what I'm going to do is I'm going to look at T plus S of A, let A and B be a scalar and U and V be elements of my vector space V. Well, T plus S of A, U plus B, V is equal to T of A, U plus B, V plus S of A, U plus B, V by definition of addition. So using the definition of addition, which I have up here, I'm able to define addition. And now I can use the fact that they're linear transformations. So this is AT of U plus BT of V plus AS of U plus BS of V as S and T are linear transformation. And now here, what I want to show, my goal, which I'm just going to write off to the side here, my goal is to show that it's equal to a t plus s of u plus b t plus s of v. And you could either stop here and look at what this here equals by expanding using the definition of addition, expanding, or we could try and manipulate this expression. Now I'm going to manipulate this expression. Feel free to start with this on the right-hand side and show that they both get to something that looks like this. So this here equals AT of u plus AS of u plus BT of v plus BS of v as vector addition in W is commutative. Now this equals A T of U plus S of U plus B T of V plus S of V by, I think this is A6 in W. So it's the sixth axiom in W. Don't quote me on that. I would definitely look up and recall exactly what axiom allows me to do that. But now this is A T plus S of U plus B T plus S of V by definition of addition of linear transformations. And this gives me exactly what I'm looking for. I have a left-hand side equals right-hand side. Therefore, by the theorem from class, T plus S is a linear, or is in a set of linear transformations from B to W. And the big thing here is that I'm looking at this, the set of vectors is my linear transformation. It's any linear transformations. It's not the vectors V, it's not the vectors W. It's the linear transformations from V to W. Okay. So to show that, the next thing that you would show is that the dot operator, which takes a field entry and a vector space, and it maps that to your vector space, you need to show that CT is a linear transformation from V to W, given T is a linear transformation from V to W. And I'm going to leave this as an exercise. So this is that I'm going to leave for you guys to do. It's very similar to what we've done here. We've taken a linear transformation and we've shown that it maps V to W. Now, for A1, A2, A5 through A8, we are proving equality. So I'm going to do A1 and A2 to kind of show you how that equality statement works. But then the remaining equality statements are similar. You take your left-hand side, you take your right-hand side, and you show that they're equal. You just need to make sure that you got what your vectors are. And your vectors are your linear transformations.